Hello everyone and welcome to a new lecture. In this video we're going to talk about terminal points. Okay, so before we do that, let's talk about the circumference of a unit circle. Okay, so this is a unit circle that we have right here. That means the distance from here to here. Okay, so this distance is 1. From here, for example, to here, this is 1. Okay, so if C stands for the circumference of this unit circle, then if you want to measure it, it is basically 2 pi r. Okay, however, r here is 1. That means the circumference of the unit circle equals to 2 pi. Okay, that means if I start right here and I go around on the unit circle, okay, a full revolution, okay, and then I end at the same place, then I have traveled a distance of 2 pi. Okay, so in geometry and in trigonometry, if you go counterclockwise, so right here we went like that, then you denote the direction to be positive. So if I want you to go a positive 2 pi, you will go like that. However, if I want you to go a negative 2 pi, you go clockwise. Okay, so if you want to go a negative 2 pi, you start right here and you go all the round and come back to the same place. Okay, just be aware of that. Distances are in absolute value. However, for you to denote the direction, either clockwise or counterclockwise, if you go counterclockwise, it will be a positive. Okay, if you want to go clockwise, it will be negative. Okay, so let's talk about the positive. So from here, okay, all the way around to here, it will be 2 pi. That means if I start right here, so if I delete some of this, if I start right here and I ended right here, okay, that means I haven't traveled a distance of 2 pi. I have traveled half of that, so 2 pi over 2, it will be pi. So from here to here, this is a distance of pi. From here, the whole revolution is a distance of 2 pi. Okay, what is half of that? What is half of pi? Well, half of pi will be pi over 2. So if I travel from here to here, this will be a distance of pi over 2. Okay, and from here to here, okay, this is 3 pi over 2. Okay, and the full thing is 2 pi. Okay, so what is terminal points has to do with all of this? Well, terminal points are those points such that your distance or your travel ends. Okay, so let me delete this. This is the unit circle. Okay, the terminal point, so if I start right here, this is always called the initial point. The point such that you have the unit circle crossing the x-axis on the right side, this is called the initial point. The point such that you end your travel on, okay, so I have to end my travel right here, this is called the terminal point. Okay, terminal meaning termination or ending, it is called the terminal point. I can end the travel that I have, okay, right here, okay, and this would be my terminal point. This is the terminal point. Okay, so the terminal point is the point such that you end your travel on, okay, when you have the unit circle, starting from your initial point. Okay, and we are trying to see what is the coordinate of the terminal point, okay, in relationship with the distance that you make. Okay, so if I make a distance of, so if I start right here, I make a distance of pi and I come right here. Okay, this is the terminal point. This is the terminal point. I want to know what is the coordinate of that. What is the x and y? Okay, that is basically what terminal points are, and that is what we are going to do in this lecture. We will try to find those coordinates depending on how much we travel along the circumference of the unit circle. Okay, so let's start with finding the coordinate of the simplest terminal points. So let me delete some of this so we have some space. So we said that the radius from here to here is 1. Okay, that means from here to here is also 1, from here to here is also 1, from here to here is also 1. Okay, so if I travel a distance, so we said that the distance from here to everything is 2 pi. If I divide that by 4, it will be 2 pi over 4, it will be pi over 2. Okay, so from here to here, this is a distance of pi over 2. What is the coordinate of this point right here? Well, this is the radius, okay, it is on the y-axis, y equals to 1 and x equals to 0. So the terminal point, x equaling to 0 and y equaling to 1. Okay, so what happens if I travel more than that? I come right here. Okay, I have a terminal point right here. Well, this is x equaling to -1 and y equaling to 0. So this is -1 and 0. Okay, so if I travel more than that and I come right here, okay, at this terminal point, the coordinate of it is y equaling to -1 and x equaling to 0. So this is 0 and -1. Okay, and if I travel all the way to here, okay, this is x equaling to 1 and y equaling to 0. Okay, so as you can see, the opposites are just equal in value, opposite in direction, or opposite in sign. Here I have the terminal point to be 1 and 0, the coordinate of it. I have here to be -1 and 0. Here I have 0 and 1, and here I have 0 and -1. Okay, so let's do this. And I'm going to denote the distance by t. So if I have a distance of pi over 2, I will have the terminal point to be 0 and 1. Okay, if I have t to equal to pi, I have the point to be -1 and 0. Okay, if I have t to equal to 3 pi over 2, I have p to equal to 0 and -1. And if I have t to equal to 2 pi, this is the same thing for t equaling to 0. So if I don't travel anything or anywhere, I'll have the point or the terminal point to be at 1 and 0. Okay, so that means if I start right here, if this is my initial point and I come to travel a distance of pi, I'll have a terminal point of -1 and 0. Okay, if I go around another time and come back to the same place, so I go like that and come back to the same place, okay, I come back right here, I will still have the terminal point to be -1 and 0. Okay, so for t equaling to pi, and for t equaling to 3 pi and 5 pi and 7 pi, for all those travels or for all those distances, I have the p to equal to -1 and 0. They don't differ. The same goes for t equaling to pi over 2. So if I come right here, okay, I'll have the terminal point to be 0 and 1 for the unit circle. If I go around a full circle and come back to the same place, I'll still have the p or the terminal point to be 0 and 1. However, the distance will be different. Okay, be careful about that. So now let's see the terminal point for other distances. So if I delete all this, so here is our unit circle. So if I don't go until pi over 2, so if this is pi over 2, I don't have the distance from here to here. Okay, this will be my terminal point. I have it halfway through. I have it until here. Okay, what is the terminal point right here? Okay, so if this is pi over 2, we forgot the 2. Pi over 2 over 2, this point right here will be pi over 4. So if I travel a distance of pi over 4 on the unit circle, what will be my coordinate at that point? What will be the terminal point? Okay, so how can you find that? Well, it's very, very easy. Okay, so the equation, so let's do it right here. Okay, so we are trying to find the terminal point for t equaling to pi over 4. Okay, what is p? Well, p will be, or will have an x and y. So for the unit circle, the equation of it is x to the 2 plus y to the 2 equaling to 1. Okay, and this point that we have right here, such that the terminal point is on it, which is pi over 4, is exactly on the line y equaling to x. Okay, because imagine it, we have a unit circle. Okay, this quarter right here, so from here to here, this is pi over 2. Halfway through will be pi over 4, and halfway through will be on the line that goes halfway through here. Okay, and that line is y equaling to x. Okay, so y equals to x. This is, we have two equations right here. This is the second equation and this is the first equation. I can put the second equation to the first equation. So y equals to x, and instead of this y squared, I can write x squared. So I will have x to the 2 plus x to the 2 equaling to 1. And from this, we have 2x to the 2 equaling to 1. And from this, we have x to the 2 equaling to 1 over 2. And from this, I have x equaling to positive negative 1 over the square root of 2. Okay, that means this point that I have right here at t equaling to pi over 4, it will equal to, so the x of it and the y of it, okay, equals to plus minus 1 over the square root of 2. Which one is it? Okay, so here in this quadrant, any x and y that I have, both of them will be positive. So it will be positive 1 over square root of 2. So it will be 1 over square root of 2 and 1 over square root of 2. Okay, so as you can see how we found the terminal point for t, or for distance, such that it is pi over 4. It is just like that. Okay, that means, so let me delete this. If this point, this is pi over 4, okay, and the terminal point of it is 1 over square root of 2 and 1 over square root of 2, okay, that means, so this is 1/2, okay, suppose this is a, this will be a. Right here, this is the halfway through, this will be a, and this will be 4a. Okay, so 2a equals to pi over 2, and 4a equals to pi. Okay, that's how I want you to think about it. So the distance a equals to pi over 4, so a equals to pi over 4, and the terminal point of it is 1 over square root of 2 and 1 over square root of 2. Okay, 2a equals to pi over 2, and the terminal point of it is 0 and 1. Okay, how about 3a? So right here, okay, if I travel this much, I have a terminal point right here, okay, at 3a. It will be, so if this is pi over 4, this is pi over 2, okay, this will be 3 times pi over 4, so it will be 3 pi over 4. So 3a equals to 3 pi over 4. It will have the same terminal point, however, depending on whether x or y is negative or positive, it will change. So the terminal points will be still 1 over square root of 2 and 1 over square root of 2. However, here x is negative, so it will be negative 1 over square root of 2. Okay, so at t equaling to 3 pi over 4, okay, we have the terminal point of negative 1 over square root of 2 and 1 over square root of 2. Okay, so let me delete this. So this is a, this is 2a, this is 3a, this is 4a. How about 5a? This is 5a, and it equals to, and this is 6a. Okay, it equals to, this is 7a, this is 8a. Okay, so 5a equals to, so if this is 3 pi over 4, okay, this will be 4 pi over 4, it equals to pi, okay, so this is pi, so 4a equals to pi. 5a, it will equal to 5 pi over 4. Again, it will have the same terminal point, however, depending on whether the x or y is negative in this quadrant. Okay, if t equals to 5 pi over 4, we have the terminal point to be, so here we have the x negative and y to be negative, so it will be negative 1 over square root of 2 and negative 1 over square root of 2. So if they ask you what is the terminal point at 5 pi over 4, you will say it is negative 1 over square root of 2 and negative 1 over square root of 2. Okay, and 6 pi, so right here is 3 pi over 2. The terminal point is 0 and negative 1. Okay, at 7a, it will be 7 times pi over 4, so it will be 7 pi over 4. Here we have the y to be negative and x to be positive. So at t equaling to 7 pi over 4, we have the terminal point to be 1 over square root of 2 and negative 1 over square root of 2. Okay, and at 8a, okay, or at 2 pi, 8a equals to 2 pi. At 2 pi, we have the terminal point to be, yes, to be 1 and 0. And we have it right here. At 2 pi, we have it at 1 and 0. So we found 4 basic, okay, terminal points, the coordinates of them, and we found another 4 points. Okay, so let me delete all this. Okay, so now we know the terminal points for pi over 2, for pi, for 3 pi over 2, for 2 pi, for pi over 4, for 3 pi over 4, for 5 pi over 4, and for 7 pi over 4. Okay, so pi over 4 if you have studied any geometry, pi over 4 is 45 degrees, okay? So this is 45 degrees. And we're gonna talk about this in more detail in the coming chapter. However, this is 45 degrees. This is pi over 2, which equals to 90 degrees, okay? We are interested in two more degrees, which are 30 degrees and 60 degrees. We want to know the terminal points at those angles. Okay, so 30 degrees equal to pi over 6. Okay, so 30 degrees equal to pi over 6, and 60 degrees equal to pi over 3. So we are interested in pi over 6 and pi over 3, the terminal points at those angles. Okay, so pi over 6 looks like this. This is pi over 6. So if I travel this much, this will be pi over 6. Okay, pi over 4 will be right here, and pi over 3 will be right here. And this is pi over 3. What are the terminal points at those angles? Okay, at those distances? Well, so if I delete this, at t, okay, at t equaling to pi over 6, okay, our p will equal to, so I'm just gonna tell you the terminal point, okay, at t equaling to pi over 6, our p will equal to the square root of 3 over 2 and 1 over 2. Okay, so right here, at t equaling to pi over 6, our terminal point is the square root of 3 over 2 and 1 over 2. Okay, how about pi over 3? Well, this is y equaling to x. Okay, if I reflect pi over 6 around y equaling to x, okay, I'll have pi over 3. I'll have this point. Okay, so that means I'm just going to swap the domain and range of this point, and I'm going to get the terminal point of pi over 3. So it will be 1 over 2 and the square root of 3 over 2. Okay, this is pi over 3. This is pi over 6. Okay, so pi over 6, if I add 2 pi over 6 to each other, so pi over 6 plus pi over 6, it will be 2 pi over 6, it will be pi over 3. It will be this point. It will be 60 degrees. Okay, so if I add 3 pi over 6's to each other, okay, so pi over 6 plus pi over 6 plus pi over 6, it will be 3 pi over 6. It will be pi over 2. So I will get to here. Okay, if I add 4 of those, so 4 pi over 6's, so pi over 6, say let's time 4, okay, it will be 2 pi over 3. And 2 pi over 3 will be kind of right here. And the terminal point of 2 pi over 3 will be the same as this if I just reflect it around the y-axis. So it will be negative 1 over 2 and the square root of 3 over 2. Okay, so negative 1 over 2 and the square root of 3 over 2. Okay, so let's delete all this. So for 2 pi over 3, so for t, so equaling for 2 pi over 3, we have p being the negative 1 over 2 and the square root of 3 over 2. Okay, let's not forget to write pi over 3. So for t equaling to pi over 3, our p will be reflected around the line of y equaling to x. So it will be 1 over 2 and square root of 3 over 2. And don't worry, eventually I'm going to show you a way in order for you to memorize all this very, very quickly. But here, I want to show you how we know all this. So you can be able to derive these values in case you forget what are the values. Okay, so for t equaling to pi over 3, our terminal point will be 1 over 2 and the square root of 3 over 2. Okay, so 4 times pi over 6 will get me here. 5 times pi over 6 will get me here. So 5 pi over 6, okay, will be here, and the terminal points of it will be the same thing, exactly that we have right here. However, reflected around the y-axis. If I reflect a point around the y-axis, the x of it will be negative. So it will be negative the square root of 3 over 2 and 1 over 2. Okay, so For t equaling to 5 pi over 6, I have the p to be negative square root of 3 over 2 and 1 over 2. Okay, so 6 times pi over 6 will give me pi over give me here. 7 times pi over 6 will give me right here. So this is 7 pi over 6. Okay, what is 7 pi over 6? Well, it's exactly pi over 6. Okay, however, we will have, so any point that we have in this quadrant, the x of it and the y of it will be negative. So it will be negative the square root of 3 over 2 and negative 1 over 2. So for t equaling to 7 pi over 6, we have the terminal point to be negative square root of 3 over 2 and negative 1 over 2. Okay, for 8 pi over 6, which equals to 4 pi over 3, okay, which will be right here, so 4 pi over 3. The terminal points, so it will be exactly opposite to pi over 3. It will be negative 1 over 2 and negative square root of 3 over 2. Okay, so this is 4 pi over 3. So 4 pi over 3 equals to 8 pi over 6. Okay, for 9 pi over 6 basically equals to 3 pi over 2. 3 pi over 2, the terminal point of it is 0 and minus 1. For 10 pi over 2, which equals to 5 pi over 3, we will have the exact terminal point as 2 pi over 3, so as this one. However, here we will have the y to be negative and the x to be positive. Okay, so it will be 1 over 2 and negative square root of 3 over 2. Okay, so for t equaling to 5 pi over 3, okay, we have p equal to 1 over 2 and negative square root of 3 over 2. And finally, so 5 pi over 3 equals to 10 pi over 6. Okay, for 11 pi over 6, which equals to right here, 11 pi over 6, the terminal points are exactly as 5 pi over 6. However, here we will have the y to be negative and the x to be positive. So it will be the square root of 3 over 2 and negative 1 over 2. Okay, so for t equaling to 11 pi over 6, we have p to be the square root of 3 over 2 and negative 1 over 2. Okay, so if I travel pi over 6, I will have this terminal point. If I travel pi over 3, I will have this terminal point. So if I travel 2 times pi over 6, I'll have this terminal point and so forth. So basically, this is how we come up with the terminal points. And now I want to review everything that we have learned and show you how you can memorize these values. So if we go down, we have this unit circle. Okay, all you have to remember is 2 values. Okay, so remember the value of pi over 6. Okay, so if I travel pi over 6, I'll get to here. This will be the terminal point, and this is pi over 4. Okay, so I can travel half of this quarter. I'll get to pi over 4, or I can travel up to pi over 6. So the terminal point for pi over 6, the coordinate of it is the square root of 3 over 2, okay, and 1 over 2, okay, and the coordinate of the terminal point of pi over 4, if you travel the distance of pi over 4 on the circumference of the unit circle, you will have, as we mentioned, 1 over the square root of 2 and 1 over the square root of 2. Okay, this will lie on the line y equaling to x. Okay, you can delete this. So all you have to do is just remember these 2. The other ones that we have, okay, we can get it by reflection. Okay, so if I travel 2 pi over 6s, I'll be getting to pi over 3. This is pi over 3. The value of the terminal point of pi over 3 is the same as pi over 6, however reflected around the y equaling to x, around that line. So this is the line y equaling to x. If I reflect pi over 6, this point, it will be pi over 3, okay? And the value of the terminal point, or the coordinate of the terminal point, will be the same thing, the square root of 3 over 2 and 1 over 2, however reflected around the y equaling to x around this line. Okay, that means I'm gonna change, okay, or I'm gonna interchange the domain and range. Therefore, I'll have 1 over 2 as x and the square root of 3 over 2 as y. Okay, so far all I have done is just I memorized pi over 6, the terminal point of pi over 6, and the terminal point of pi over 4. The terminal point of pi over 3 is the same as pi over 6, however, you change the x and y. Okay, so after pi over 3, if I add another pi over 6 to it, I'll get to pi over 2. Okay, and if I add another pi over 3, I'll get to 2 pi over 3. I'll reach here, so 2 pi over 3. Okay, so as you can see, from here to here, I'm just going to add, so from here to here, if this is a, I'm just going to add an a to get to here, and I'm going to add an a to get to here. Okay, so this is 2 pi over 3. What is the terminal point of it? Okay, well, all I'm going to do is I'm going to reflect around the y-axis. Okay, so if I reflect everything that I have right here around the y-axis, I'm going to get all the terminal points that we talked about. Okay, so this is 2 pi over 3. The next point, it's going to be 3 pi over 4. Okay, because from here to here is pi over 4. This is 2 of the pi over 4s. Okay, this is 3 pi over 4. Okay, and then the next one that I'm going to get is going to be 5 pi over 6. So if I reflect everything around the y-axis, I'm going to get all these values. Okay, so if I reflect pi over 3 around the y-axis, all I'm going to change is I'm going to change the sign of the x from positive to negative. Therefore, it will be negative 1 over 2 and square root of 3 over 2. Okay, for 3 pi over 4, it's going to be negative 1 over 2 and 1 over 2. Okay, and for 5 pi over 6, it's going to be negative square root of 3 over 2 and 1 over 2. Okay, as you can see, it's very, very easy to come up with these values. All you have to do is just to memorize pi over 6 and pi over 4, the terminal points of those two distances. Okay, so now what? Well, if I reflect everything around the x-axis, I'm going to get everything else. Okay, so the next point that I have, so this is 5 pi over 6. 6 pi over 6 is going to be right here. This is 7 pi over 6. Okay, this is 8 pi over 6. This is 9 pi over 6. This is 10 pi over 6, which equals to 5 pi over 3. And this is 11 pi over 6. Okay, how about the 45 angle, or the pi over 4? Okay, so this is 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. So right here, I have 5 pi over 4. This is 6 pi over 4. This is 7 pi over 4. 7 pi over 4. Okay, so let's not mix these two. Okay, and let's not forget, so this 8 pi over 6 equals to 4 pi over 3. Okay, so if I reflect everything around the x-axis, I'm going to get all these values. Okay, so if I reflect this point around the x-axis, this point is going to be this point. Okay, so the terminal point right here is going to be, so here all the x's and y's are negative, so it's going to be this value, however, everything negative. So it's going to be negative square root of 3 over 2 and negative 1 over 2. Okay, this one, it's going to be, so we forgot the square root right here. So here it's going to be negative 1 over square root of 2 and negative 1 over square root of 2. And for here, it's going to be, so if I reflect it, this is going to come here. Okay, my picture is not perfect, but you get the idea. It's going to be negative 1 over 2 and negative square root of 3 over 2. Okay, how about here? If I reflect it around this axis, all the points that are in this quadrant, the x of them will be positive and the y of them will be negative. So this point is going to be reflected right here, so it's going to be, so the x of it will stay positive and the y of it was going to be negative. Okay, for this one, okay, it's going to be 1 over square root of 2 and negative 1 over square root of 2. And for this one, it's going to be square root of 3 over 2 and negative 1 over 2. Okay, so that's how we find the terminal point of all these. All you have to do is just remember these two terminal points. Okay, And then you're going to reflect around the y equaling to x-axis, that line, you will get this one. And then reflect it around the y-axis, you will get all these three. And then reflect everything around the x-axis, you will get this, 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 and this, this, this. And then all you have to do is just to account for the fact that if you have a point, for example, in quadrant 3, you'll have both x and y negative. If you have it in quadrant 2, you'll have x negative and y positive. Okay? And as I mentioned, I'm going to attach a document to this lecture. You will have all this information in front of you so you can memorize it and you can have it when you need it. Okay? And with this, we come to the end of this lecture.